Hello, and welcome to the unexpected part 2 of our stream for our Chasing Coral. We're going to go ahead and get started with our Q&A with our expert panels. This Q&A will be once again hosted by the Surfrider Washington Regional Manager, Liz Scottman, and she will be joined by Whitney Hoot, the Coral Reef Resilience Coordinator for the unincorporated territory of Guam, and Dr. Meredith Everett, biologist for NOAA's Northwest Fisheries Science Center. And welcome to all of you. And with that, Liz, go ahead and take it away.
Yeah, so we'll probably kind of hold off a little bit on questions for a few minutes just as people start to roll in. Because we've had some technical difficulties. Am I coming in okay, loud and clear, or is it echoey at all? You guys can hear me okay?
I can hear you just fine.
Awesome. Yeah, so I am Liz Scottman. I am the Washington Regional Manager for Surfrider Foundation. And so I help support the 5 volunteer-run chapters that we have here in Washington State. And the Seattle and Olympia chapters have teamed up to host a series of film screenings. And this was our inaugural attempt, and it was straight up a 2020, no doubt about it. So we apologize for all the technical difficulties. The story is we got all the correct permissions going through the producers of the film for Chasing Coral, and used all of the resources they have for their toolkit that they freely provide for things like this. But because it is streamed from Netflix, and we were streaming it to YouTube and Facebook, we got flagged for a violation of terms of service. And they systematically shut down all the streams that we had going, even though we tried to set up multiple options in this kind of event. But foiled by technology once again. So we apologize for all the challenges and difficulties. If you tried to view it and couldn't, it is available on Netflix. So you can watch it if you have an account. And so if you haven't yet, we definitely recommend you checking it out because it's a great film. Do we have any, I guess I'll open the floor to questions. I do want to thank Dr. Meredith and Whitney for taking their time and being willing to share their expertise and insight, because I know I have a ton of questions. And I will try to grill them on them. But I do want to open the floor if anybody has any questions to start with, or if Meredith or you have anything you want to say about the film or yourselves, or any further introductions you want to make, feel free.
I'll wait and see what kinds of questions we get.
Well, I guess why don't you guys introduce yourselves a little bit? Because I feel like we got a little bit of an introduction, but I realized that wasn't public. So Whitney, I'm going to put you on the spot first.
Hi, everyone. My name is Whitney Hoot. I work on Guam. I coordinate the Coral Reef Initiative for the island of Guam, which is an unincorporated territory of the States located in the Western Pacific. Kind of near Japan, kind of near the Philippines, but really kind of in the middle of the ocean. And I've been out there for about 5 years. And in addition to working for the government, so for the government of Guam, I am also a PhD student. I'm just about to wrap up my 2nd year, and my research is focused on coral reef restoration.
Awesome. Thank you for that. And Meredith, would you like to give a brief intro on what you do?
Sure. I'm Meredith Everett. I work for NOAA's Deep Sea Coral Research and Technology Program at the Northwest Fisheries Science Center, where I'm in the Conservation Biology Department. I'm a deep sea coral biologist. I do genetics and connectivity studies on deep sea corals, everything from the Arctic and Alaska all the way down to Southern California and areas of the Central Pacific. And all the corals I work on are 100 meters deep or deeper, except in the Arctic, where they can those deep sea species can come up to the surface.
Very cool. Very cool. Awesome. Well, I love that we have both some tropical coral representation and some deep sea West Coast coral representation. So I'm really excited to hear sort of how those two different kinds of populations are doing and how we study them. So I will open the floor to questions if anybody has them. And if not, I've got bunches. People are being shy. That's all right. I'll start with one. So the film talks about warming effects. This is going to be first for Whitney. What kind of effects have you seen in Guam, and sort of your take on it as far as the populations in your area of the world? And then Meredith, when she's done, I'll pass it on to you. And I'm pretty curious to see how the deep water corals are faring, if they're affected by temperature or if they're more of like a reservoir. So take it away.
Sure. So on Guam, we've actually seen pretty severe bleaching in 2013, 2014, 2016, and 2017. So during that time period, we lost about a third of all of our shallow corals. And that's everything from about, say about 10 meters, so 30 feet and shallower. So we had really significant coral loss during that period, and that's kind of following several decades of decline due to localized human impacts like overfishing and pollution. So this was kind of a big shock to us, and the way that the climate patterns work and the way that the ocean warms, we tend to see warming before Australia. So Mark Aiken, who was in the film, is a good colleague of mine, and he runs this program called Coral Watch, where you can get projections for what you're expecting to see for bleaching. And we keep track of ours and we look at it, and that's part of my job, is to see what do we expect to see for bleaching this year, and we get projections about 16 weeks out. And we tend to have it before they do in Australia. So we actually they say that the most recent global bleaching event, I believe, was 2014 to 2017, and we actually kind of started it in 2013. So in some ways, at the time in 2016, we had actually seen more severe, repeated, long-term bleaching events in quick succession than almost anywhere else in the world, in the Mariana Islands where Guam is. So we've definitely seen the impacts and seen how devastating it can be on Guam.
Thank you for that, but I wish Meredith, we have some questions on, are you seeing bleaching in deep sea corals, and how are our populations out here doing?
So we don't see bleaching in deep sea corals, but that's partially because all the species I work on live largely out of the photic zone. So they're so deep that they don't actually ever receive sunlight. So we don't have that symbiotic algae that shallow water corals have. And so our temperature effects are very, very depth dependent. A lot of the species I work on are so deep that they are in this kind of deep cold water pool that largely at this point is unaffected by surface temperature changes. But we are seeing that temperature shift penetrate into some of the shallower depths we work at, in that 100 meter zone, down to that 300 meter zone. And that can be really detrimental because the corals I work on in the deep sea are so used to such a stable temperature environment, they can be pretty sensitive to temperature shift. And the other thing we encounter is some of these species, we've got a species called red tree coral that I work on that in places like Alaska and British Columbia, while it's normally found at about 300 meters, which is about that's about 1,000 feet. You can find it all the way up shallow to recreational dive depths. You can find it within about 100 feet of the surface in areas where the water is really cold. And those much more shallow populations can be very sensitive to the temperature change. And we do see stress in them.
Okay. And that's a great follow-up question from Sherry. Do corals regenerate after bleaching, and can they kind of regrow in areas? So Whitney, I know you do a lot with like coral restoration and things like that. So do you want to start us off with that?
Absolutely. So corals absolutely can regenerate after bleaching. So a bleached coral is not dead. Essentially what happens when they bleach after they lose their symbiotic algae, these zooxanthellae, is that they're starving. So for many coral species, particularly like what Meredith was talking about, those that are in the photic zone that depend on these algae that get a lot of light. They depend on these algae for a lot of the nutrition that they get. So when they're bleached, they're essentially starving and they're vulnerable to predation, vulnerable to disease. But if the water temperature goes back to normal, and the bleaching threshold is generally kind of very broadly considered to be about 30 degrees Celsius, which I think is about 86 degrees Fahrenheit. If the temperature goes back down, they can recover. And an amazing thing about corals is that they're actually able to uptake new zooxanthellae from the water column. So just because they've lost their zooxanthellae doesn't mean they're doomed. So they're able to bring in new zooxanthellae and get those algae back, to give them back their color, give them back their nutrition, and keep growing. We've also found that with corals, what's really important, so kind of a buzzword in coral reef conservation and management is this term resilience. And part of the idea behind that is you try to manage and reduce your localized stressors. So like overfishing and pollution, all of these things that are kind of happening at smaller spatial scales. And you try to reduce them to make your reefs healthier and stronger. So on reefs, algae, so fleshy macroalgae, these are essentially plants that grow on the water. They grow really fast and they compete with corals for space in this kind of shallow part of the reef where they get a lot of light. So if you have a lot of, if your reefs aren't overfished and you have a lot of herbivores like parrotfish and rabbitfish, they will kind of maintain the algal population. And then if you don't have a lot of pollution, so obviously when you have nutrient runoff like nitrogen and phosphorus, that feeds algae. And if you have really clean, clear water, you don't have a ton of nutrients in your water, then there's not a lot of food for those algae to grow. So, the majority of a coral colony can die or it can be severely bleached, but it can come back as long as it kind of has those conditions that really facilitate its health and its regrowth.
Meredith, what kind of impacts do we have on our deep sea corals if they're not experiencing bleaching because they don't, have those zooxanthellae inside of them necessarily?
One of the big focuses of our research in terms of climate impacts is the effect of ocean acidification, because a lot of the species we work on do have that same internal skeleton, or I work on a lot of soft corals. They actually have a skeleton that's made up of these tiny sand grains that interlock called sclerites. And those are all susceptible to acidification, just like you would see in shallow water species. And those more acidified waters can penetrate down deep to the areas we work. The other big impacts that we monitor for are fishing. Any bottom contact fishing gear can have large effects on deep sea corals, as well as the kind of new up and coming potential threat is deep sea mining. There's big pushes in places like the Central Pacific to start collecting manganese nodules and other minerals off the seafloor, and you can have deep sea coral communities in the areas where this mining can occur. So we're trying to kind of, since we're in the very early stages of those processes, we're trying to get ahead of that in terms of management and documenting what's there in some of these deep sea habitats.
Nice. I do want to plug that Surfrider and some of our partners like Pew Charitable Trusts are working on a seabed mining prohibition in Washington's territorial waters. So if you haven't heard about it, check out some of our Surfrider channels, and there's some more information on what it is and the threats that it poses to our waters. So great. What other kind of questions do we have in here? Are there any types of corals more at risk, and is that risk sort of equally spread out?
That's a great question. So absolutely. And what we have found is that a lot of branching corals. So if you're familiar with the Caribbean, this is largely Acropora cervicornis and Acropora palmata, which is these are cervicornis is like a staghorn coral. So they have these like big branches, and there's lots of different types of branching corals. And what's really cool is that all the different types of them, they provide habitat for different sizes and types of organisms. So you'll have ones that have like really wide branches, and those you can get kind of like, you know, a relatively big fish or a relatively big invertebrate that hides in that space. And then you have ones that are smaller branches that are closer together, and you get smaller smaller fish and invertebrates that hide in there. So all of these different types of corals play a different role in their ecosystem. So branching corals grow relatively quickly. It's still pretty slowly, like you know, a dozen centimeters a year maybe. But in contrast, you have mounding or boulder corals in the Caribbean. They're often called brain corals. And, you know, they look like a boulder, or like, you know, half of a sphere. And these guys grow much more slowly. You know, maybe a centimeter a year, or even just a few millimeters. So with these branching corals, they put a lot of their energy into depositing skeleton because they grow really quickly. So they are actually much more vulnerable to bleaching because that's kind of where they've put their energy. And with these boulder corals, they can put more of their energy into lipid storage, so fat storage. So basically developing energy reserves that these branching corals just don't do. So what we found is that the branching corals, they bleach quickly and they die more quickly than the boulder corals do. However, because they grow quickly, if the conditions are right and you have, you know, a good number of herbivorous fish and not too much pollution, these branching corals can grow back relatively quickly. It takes longer for these boulder corals to grow back. So there's definitely different types of coral that respond differently to bleaching. So I would say that the branching corals, they're more likely to have good recovery. And these boulder corals, they're more likely to resist bleaching in the first place.
Meredith, how does that compare with some of our deep sea corals and how quickly they grow and recover?
There's a pretty large spectrum in deep sea corals. You have some species that will come up and have relatively quick growth. Some of our small plixaurid sea fans and some of the little mushroom corals really only live for about 30 years. But in some of the deep sea species like the bamboo corals and the gold corals, you can have individuals that are hundreds of years old. Some of the deep sea black corals can be up to about 1,000 years old. And those species have very, very slow growth rates. So you're thinking it's only a centimeter or so a year. And so, yeah, we'll see bamboo corals that are these big, like candelabra shaped fans that are about 1 meter across. And at that size, they're about 200 years old.
Wow, that's crazy.
And, yeah, so when we see impacts, the recovery rates are variable, but if it's an impact on one of these really slow growing, long lived species, it takes a long time for them to come back.
We have kind of a fun, lighthearted question, but do you guys know of any other glowing corals? Because in the film they talked about corals that fluoresce. Do you guys have any experience with glowy corals?
So everything I work on, because I'm working in the deep sea, a lot of deep sea corals are actually bioluminescent. And I think there's actually a video on YouTube of a bamboo coral in Hawaii that they took the submersible and pinched it, and you can watch these waves of bioluminescent travel up and down the coral. A lot of the sea pens, which are also a species of coral, are bioluminescent. And so they just, if you touch them in the right way, they'll light up.
Nice, very cool. We have kind of a question, a little bit of a shift. That talks kind of about your journeys as marine biologists. And I think that's an important story to tell. Like, you guys are on the front lines fighting for our corals. And so, if you want to kind of touch on, Meredith, I'll let you keep talking first this time, but sort of your journey and what got you interested in it and sort of what you love about studying corals.
Sure. So when I started school all the way back in the undergraduate, I knew I wanted to do marine science. But at that point, I was really thinking I was more focused on kind of coastal ecology. But I got the opportunity to work in a genetics lab at the University of Washington's oceanography department. And at that point, I got really into using genetic tools to study marine communities and went on to continue that into grad school. And so through that whole process, I've been able to work on everything from algae in Puget Sound to baitfish in the Gulf of Mexico to killer whales to salmon and most recently corals. And so for me, it was a process of I knew I wanted to do marine science, but then I got really into using a specific tool set to work on marine science. And corals have been my focus for the last 8 years or so in deep sea communities. I find it really interesting to work on them, partially because a lot of the species I work with some of them are unknown, and some of them were defined in the late 1800s, but very little work on them has been done ever since. And so it's very ground up science. We're still answering basic questions like how long do they live? Where do they live? What do they eat? How do they interact with one another? How are they important to local fish communities in the deep sea? And so you're starting from ground zero and kind of building a whole new toolbox and information set.
Sweet. That's true. There's so much we don't know about the deep. Whitney, what about your story? How did you get on a tiny rock in the middle of the Pacific?
So my story is probably more meandering. So I actually didn't know that I wanted to be a coral biologist or coral ecologist is probably how I would describe myself until I guess when I was doing my master's degree. So for my undergraduate degree, I actually majored in sociology because I changed my major 5 times and I finally was like, oh God, I got to pick one. And I went down the whole list and I got to the S's before I was like, okay, I haven't tried this one yet. And that sounds okay. And then I minored in environmental science. And then I was going to school in New York and I hated it so much that I moved to Micronesia to be a volunteer teacher for a year. So I was living on a small island in the Federated States of Micronesia. And that's when I really, really started scuba diving a lot. And then I went to the University of Maryland to do my master's, actually in the same program that Liz did. And so that was a program in conservation biology and sustainable development. When I started, I thought I wanted to do more of the sustainable development angle. And I found that I was really enjoying my biology classes and my ecology classes so much more. So I started focusing on that. And because of my love for 1, warm water, and 2, coral reefs, I ended up doing this, and I did my master's research in Malaysia on coral reef restoration. And then right as I finished grad school, I got a fellowship to go out to Guam through the National Coral Reef Management Fellowship, which is a great program. Highly recommend checking it out if you've got a bachelor's degree or a master's and you're interested in, kind of exploring, a career in coral reef management or research. I'd never thought I would work for government, but now look at me, I've been doing it for 5 years. And then, kind of when I was doing my master's was when I realized I wanted to do a PhD. But I think if you're something that I think there's no like one right path if you want to get into marine science. If you want to go straight in, do a bachelor's and go straight into a PhD, that's awesome. If you don't want to do that and you want to work in, a different field or work in management or conservation and take your time, I think there's a lot of different ways to do it. And sometimes academia can really like push us towards a certain direction. But I think that like getting into taking classes and learning as much as you can, and that can all kind of help you get to where you want to go. But there's no one path. Do what pleases.
Follow your heart. No, that's a great. Like academia is definitely like a standard path. But if you want to do sustainable tourism, you can still do a lot to help reefs with the dive industry and the fishing industry. You can work in fisheries, and so there's a lot. If you like technical things, I know Meredith probably has stories of piloting ROVs and going off on ships and playing with all sorts of high tech equipment and sensors. So there's a lot of paths you can take.
Yeah, and a lot of different ways that you can, some people spend all their time in the water. Some people don't spend that much time in the water, and it just kind of depends. What's the path?
what floats your boat. We're getting a little close to 8 o'clock. We can stay on a little later if our panelists are fine with that and people are still into it. But I do want to kind of answer at least some of the questions that are out there that kind of focus on solutions. So we have one question from Sherry is that, are there any indications that conditions anywhere are tending towards that which produce coral regrowth? And then another question earlier was, what kind of solutions do we have or things that we can help with beyond just, working on climate change in general?
Yeah, these are really good questions.
And how do you cope?
Right. Well, I've watched this film several times, and I've been a panelist after this film a few times. And it's a hard film to watch if you care about the marine environment. And as someone who works in management and conservation and does research, it is hard to maintain optimism. Nancy Knowlton from NOAA, she a couple of years ago started a Twitter campaign essentially, which is #OceanOptimism. So how do we remain optimistic in the face of all these threats? And beyond just mitigating climate change, which is a very overwhelming task and involves like a very intense level of global cooperation and political support, what can we do? And I do believe that on the local level, by reducing stressors and by trying to make your reefs as healthy as possible, you can have impacts on how much coral bleaching affects your reefs. And I do, and this is probably developed over, the last few years, but I do strongly believe that outreach and education and communication are extremely important. Very few people in this world are actually exposed to coral reefs. Not very many people go snorkeling or scuba diving. Not that many people on a global scale have actually watched Chasing Coral. And really, it's the connection to these ecosystems that makes people care. And if people don't care, there's not, as much motivation to conserve these ecosystems. And if you can't get them on that, the other thing that's really important is ecosystem services. So these coral reefs are vital to all kinds of economies all around the world. You look at the economy of Florida, of Hawaii, of Guam. This is huge. So if you can't appeal to someone's inherent love of nature or their appreciation for biodiversity, hit them with the economy approach, because there's a lot of people who care about that too.
I think I've read it's about a third of commercially important fisheries species depend on reefs at some point in their life cycle.
Yeah.
I think is about it. What about you, Meredith? Do you see any hope? How are deep sea corals?
For deep sea communities, we do, and from two standpoints. One is so the way on the West Coast we manage deep sea coral habitats is what we call essential fish habitats. So we work with the fishing communities and the fisheries management councils to designate protected zones, and in those are deep sea coral communities. And in some of the areas that this management strategy started in 2006, and areas that were closed to fishing in 2006, we have started to see in some areas signs of recovery of corals and sponges in areas that were very heavily fished previously. And then also, as we do more and more ROV exploration along the coast, we find just more and more really healthy, intact, untouched communities as we survey. So we know that there are still pristine communities down there that can act as an important source of new coral to be distributed to areas that are previously disturbed.
Right on. Do you guys have any preferred recommendations on actions people as individuals can take in their communities beyond just supporting things like, hey, fund NOAA and stop climate change? Some big picture things versus what local actions might be able to help even in a small way.
I think sharing conservation messages, whatever your bubble is, whether it's your Twitter feed or your Facebook feed. I think we have, in the 21st century, kind of this unprecedented ability to reach, not only friends, but friends of friends, people we went to college or high school with. And there is some really compelling messaging out there that I think has been developed by not usually scientists, but people who work with scientists to kind of describe why are these ecosystems important, why should we care about them, and what can we do. And I think staying on top of this kind, even generally like the Guardian, for example, is a public is a media outlet that provides a lot of not necessarily reading scientific literature, but provides content that can be shared and I think can be compelling enough that it can help change somebody's mind. And I do think that like collective action is going to be incredibly important. Support elected leaders who support climate change initiatives. I know that's kind of a broad recommendation, but that is going to be increasingly important for coral reefs, is that we have to get, even with coral reef restoration and the potential to do kind of like large scale interventions, if we can't get a handle on climate change, we're going to see big shifts in our coral reef ecosystems.
Yeah, for what I work with, for us, it's largely pointing people towards educational resources. Most people aren't aware that there are deep sea coral communities, right off the coast of Washington, Oregon, California. And so just teaching people that they're there and getting people excited about their presence. So we've had the opportunity in the last several years to live broadcast a lot of our ROV work. So whenever we've got an ROV in the water, it's being broadcast live on YouTube, and people can watch and occasionally join in and ask questions in real time of the scientists who are running the dives. And just getting people really connected to that so they know it's something there. And then we provide resources through the National Marine Sanctuaries where people can go and find resources of how they can participate and things they can look at, and educational tools. The sanctuaries have put together a whole classroom curriculum for deep sea corals, so teachers can teach about that in the class and science curriculum in the classroom. So that kind of thing.
I did check in the Nautilus live stream, and it's very soothing in these crazy times. Like, I highly recommend it. I definitely have that on in the background sometimes. I'm like, yes, nerds, talk to me. Show me like slow, cold corals just hanging out away from all this chaos. So I definitely recommend it. All right. Well, we're coming up on, we're a little bit past our time. So I'll open the floor to any last questions. And what channel can we watch the live coral cams from?
Well, for the deep sea stuff, unfortunately, our season is ended for this year because we're into the bad weather season. But starting again in about May, I believe NOAA's Okeanos Explorer will be broadcasting, and Nautilus will be broadcasting as well. So check in May with either Nautilus or Okeanos Explorer, and the Schmidt Ocean Institute also live broadcasts their dives.
We'll try to make sure to post that on our social media channels too, because it's always fun to get into your sanctuary and things like that. So. So solutions, working to fight and combat climate change, and that can be your decision at home, whether that's driving less or having a fuel efficient car, making sure you eat sustainable seafood and know where it's sourced. There's a lot of things stopping runoff, not over watering or over fertilizing your lawn. Even simple things like that can and do add up to impacts our environment. So we all can do a little part, even for reefs that are far, far away or deep, deep down in the ocean. All right. Well, I will end on one final fun question. What is each of your favorite sea creatures and why?
I'm going with the Dumbo octopus, the little orange ones that you find off the coast of California, because they're always super cute. And we usually find them out in the mud. So it's usually a dive that is otherwise not quite as interesting, but then you'll come across this really great, really cute little octopus.
Perfect.
Mine is a type of coral. It's called Uliphilia crispa. and I've probably only seen it like 4 times, and it's very small and beautiful and brightly colored, and it's made me happy every time I've seen it. But I like pretty much everything in the ocean, like sharks.
Sharks need love too. They hug with their mouths.
Love sharks.
All right. Well, thank you guys so much for spending your time and answering all of our questions. This was fantastic, and I loved every minute. And thank all of you who came and persevered through the technical mishaps and the man shutting us down and falsely accusing us of copyright infringement, which we did not. I will say it again. We had all the rights to this film, so we apologize for those difficulties. But thank you for persevering.
And thank you, Liz, to you and Meredith and Whitney for doing this. This was great. It was very informative and very much appreciated. And to everyone else, have a good evening, and thank you so much for joining us.
And make your family watch Chasing Coral over Thanksgiving. It's an uplifting holiday film. Also, just want to give a huge shout out to Drew because he made all the technical recovery happen in addition to the technical planning that was not his fault when it didn't go right. All right.
Have a good evening.
Great evening.
Thank you.
Bye.
Bye.